Working directly with SQLite databases in Android has several drawbacks. You have to write a lot of boilerplate code, you have to implement the object mapping for every query you write, it's difficult to implement database migrations, it's hard to test the database, and if you're not careful, you can easily do long-running operations on the main thread. To solve these problems, we created Room, a persistence library that provides an abstraction layer over SQLite. Here's what you need to know to start using Room in your app. Let's say that you want to have a table of users, and you want every row of that table to be an instance of the users class. You need to annotate your class with entity, define the table name, the primary key, and the column infos. Room will take care of the creation of the user table for you. To access the data in the database, you use data access objects, DAOs for short. You need to create an interface, annotate it with DAO, where you declare all the methods needed to work with the database, and write the corresponding SQL statements. Room will take care of implementing these methods for you and running each of them in a single transaction. Room supports insert, update, delete, and query. The SQL statements are checked at compile time, meaning that if you write an invalid query, you'll find this out immediately. The class that puts together the entities and the DAOs is the Room database. Create an abstract class that extends the Room database, annotate it, declare the entities and the corresponding DAOs. Let's take a closer look at the queries. All of these queries are synchronous, meaning that they will be run on the same thread you are triggering them from. If that's the main thread, your app will crash with illegal state exception. So use your preferred method of handling threads in Android and make sure you're off the main thread. Room also supports asynchronous queries when working with live data or RxJava. Even more, the queries that return live data or flowable objects are observable queries, meaning that you'll get notified every time the data in the table updates. Whenever you alter your database schema, either because you've added or renamed a new column or table, you'll need to tell Room how to handle this change. To do that, in your database class, you'll need to first update your database version, second, implement a migration class that defines how to handle the migration from the old to the new version, and third, add that migration as a parameter in the database builder. After triggering the migrations, Room will validate the schema for you to ensure that the migration was done correctly. So we have our entities, DAOs, database, and migrations. How do we test them? To test the DAOs, you'll need to implement an Android JUnit test that creates an in-memory database. The in-memory database will hold the data only for as long as the process is alive, meaning that after every test, the database will be cleared. To test asynchronous queries, add the test rule instant task executor rule to execute each task synchronously. In your app's implementation, you'll end up referencing the DAOs in other classes. To unit test those classes, just mock the DAO with the help of frameworks like Mockito. Here's another tip. Extend the counting task executor rule and use it in your expressive tests to count the tasks as they start and finish. Finally, don't forget to test the migrations. We have another handy test rule for this, the migration test helper. This class allows you to create your database in an older version and run and validate migrations. All you need to do is check that the data you inserted in the older version is also present after migration. So, less boilerplate code, compile time checked queries, ease of implementing migrations, high degree of testability, and keeping database work away from the main thread. All of these qualities of Room make working with the database easier and pleasant, helping you deliver better apps.